Okay, question 24 has a picture of a triangle that looks like this with, it's a right triangle, with this side being S, this side being T, and this side being R. That's an R, and the sides T, S, and R. Okay, so question 24 says, for the right triangle RST shown below, what is the tangent of angle R? So it wants to know the tangent of this angle right here. And if you know your trigonometric functions, you'll know tangent of any angle, we'll call that theta, is equal to the opposite side length over the adjacent side length, which just means the side touching it. Okay, so if we look at angle R here, then we can see the opposite side is right across from it, right here, is this R, and the adjacent side, and by adjacent, it's not the hypotenuse, so the side that's touching the angle, but not the hypotenuse, so the adjacent side is right here, T. So the tangent of R, if we just substitute this, we'll see the opposite side is just lowercase r over lowercase t. And that's the answer. And for further practice, we could just do the sine and cosine of these of r. Sine of theta is equal to the opposite side length over the hypotenuse length. So the sine of theta, what would the sine of theta be? Sine of r would just be the opposite side length, this r, over the hypotenuse, which is just s. R over s. And we can even do the cosine. Cosine of theta is equal to the adjacent side, or the side touching it, adjacent side length over the hypotenuse. And hypotenuse, yep. Okay, so the cosine of r would be equal to the adjacent side touching it over side length r, the hypotenuse, or s, the hypotenuse. So the cosine of r would just be t over s. And we only needed to do this one, but it's good practice to know how to do all these. You should be familiar with all these concepts for the ACT. And that's question 24. So we'll go on to question 25. And it says, a cord 24 inches long is 5 inches from the center of a circle, as shown below. I'll draw the circle as best as I can. So there's a circle like this, and then there's a cord goes across. That's supposed to be a straight line. It's 24 units long, and then there's a radius that goes straight down. It intersects this perpendicularly, so this is a right angle and this is a right angle. Two right angles here, and its length 5. And then there's a segment called r, which is the radius, and it asks us to find the length of r. Okay, so since we know that, I'll try and make this spot big right here. Pull that out. This is length 5 and this is length 24. We know that this is a right angle and this is r. It's supposed to be a straight line. I'll draw that a little better actually. R. We know that since this length 5 intersects this length 24, this chord, at a right angle, we know that it splits this in half. This 24 gets split in half. So there's 12 on this side and 12 on this side. And as you can see now, there is this nice triangle right in here. You can follow it with side length 5, 12, and r. And it asks us to solve for r, so we can just nicely use the Pythagorean theorem. It says r squared equals the leg of the triangle squared plus the other leg squared. So 5 squared plus 12 squared. And so r would be equal to the square root of all this. 5 squared plus 12 squared. and r will be equal to 13. And you didn't have to really do this Pythagorean theorem if you just knew that it's called the Pythagorean triple, that 5 squared plus 12 squared will equal 13 squared, just like 3 squared plus 4 squared will equal 5 squared. It's good to know your Pythagorean triples for the ACT, so you don't need to waste time doing this. But we'll go on to question number 26. Question 26. And it says, the length in meters of a spring is given by the equation. 26 says the length in meters is given by the equation 2 over 3 times F plus 0.03, where F is the applied force in newtons. What force in newtons must be applied for the spring's length to be 0.18 meters? So F is the force, F equals force, and that's what we're looking for. It says what force do we need to have the length, this length right here of the spring, be equal to 0.18 meters. So if we wanted to, we could just substitute this in. 0.18 equals 2/3 times F plus 0.03. And now, since we're just solving for this F value right here, we can just use basic algebraic manipulation and isolate X. So we could minus 0.03 or subtract 0.03, and we're left with 0.15 equals 2/3 F, and then we can divide, or we could multiply by 3, multiply by 3, multiply by 3, times by 3, and that equals 0.45, which equals 2F, and then we could just divide by 2, and F will be equal to 0.225, and that's the answer for F. So when the force is 0.225 newtons, then the length will be 0.18 meters. And that's the answer for question 26.